Set the anti-collision light to off. As the aircraft is stationary, set position lights to steady. Set position lights to dim or bright with the wing/tail and fuselage switch. Set master light to normal. In this position, the aircraft lights will illuminate when the main generator comes online. The FLCS is a computer-controlled, 4-channel, fly-by-wire system. It has 3 operational modes: standby gains, takeoff and landing gains, and cruise gains. The normal mode of operation is cruise gains. The FLCS is in cruise gains when landing gear is up, alt flaps is in the normal position or extend above 400 knots, or air refuel is in the closed position or open above 400 knots. At low angle of attack, the pitch axis of the FLCS operates as a G command system. As AOA increases, FLCS switches to a blended G and AOA system, providing warning of high AOA and low airspeed states. Roll rate is limited, and maximum roll rate decreases as a function of low airspeed, high AOA, and horizontal tail position. Takeoff and landing gains is active when landing gear is down, alt flaps is set to extend, or air refuel is open below 400 knots. Below 10 degrees of pitch, FLCS operates as a pitch rate command system, switching to a blended pitch rate and AOA command system above 10 degrees. Roll rate is limited as a fixed value, independent of AOA, airspeed, or horizontal tail position. In standby gains, control response is tailored for a fixed altitude and airspeed. With landing gear up at approximately 600 knots or down at approximately 230 knots, the FLCS warning and fault caution lights illuminate. A standby gains condition can be reset in flight by using the FLCS reset switch. If reset is successful, the FLCS warning light goes off. Electrical signals are generated through the stick, rudder pedals, and the manual trim panel. The signals are processed by the FLCC with signals from the air data system, flight control rate gyros, and accelerometers. The processed signals are then transmitted to the integrated servo actuators of the horizontal tails, flaperons, and rudder, which are positioned to give the commanded response. FLCS limiters are provided in all 3 axes to help prevent departures and spins. The FLCP provides malfunction indications and control. The alt flap switch is in the normal position. In normal operation, the trailing edge flaps are controlled automatically by the FLCS. They can be extended manually by setting the switch to extend. To enable fly-up protection in manual terrain following mode, set manual TF fly-up to enable. Leading edge flaps are set to automatic. In the automatic position, the leading edge flaps are controlled by the FLCS. In the lock position, they are locked in their current state. When locked, the FLCS warning light illuminates, and the pilot fault list display reports a FLCS leading edge flap lock warning message. The UFC requires main generator power. To provide alternate operation of UHF, TACAN, and IFF, set the Communications Navigation IFF knob to backup. The aircraft is powered by a single F110-GE-129 afterburning turbofan engine, producing approximately 29,500 pounds of thrust. The control system is composed of 3 major components: the digital electronic control, the afterburner fuel control, and the main engine control. The DEC is an engine-mounted, fuel-cooled, solid-state digital computer and is the critical component of the primary engine control. It controls the main engine and the afterburner. The AFC is a fuel-operated electro-hydromechanical control which regulates fuel flow to the afterburner in conjunction with the DEC. The MEC is a fuel-operated hydromechanical control which provides various control functions in all control modes. The engine fuel/control system delivers the required fuel to the engine for combustion. The main fuel pump receives pressurized fuel from the engine fuel boost pump. It provides additional pressure and supplies fuel to the MEC. The afterburner fuel pump also receives fuel from the engine fuel boost pump, provides additional pressure, and supplies fuel to the afterburner fuel control. The pump operates only during afterburner operation. In normal operations, fuel master is not operated by the pilot. In the off position, the fuel shutoff valve is closed and fuel is prevented from reaching the engine. Engine feed controls how fuel is pumped to the engine from the forward and aft fuel tanks. In the normal position, all pumps are on and CG is maintained automatically. In the forward position, fuel is transferred from the forward tank and CG moves back, while in the aft position, fuel is transferred from the aft tank and CG moves forward. In the off position, all pumps are off and fuel is transferred by gravity feed, which may lead to engine flame out during heavy manoeuvring or in negative G situations. Engine control is in the normal position. The pilot can select two modes of operation: primary and secondary. Primary mode provides unrestricted engine operation throughout the entire flight envelope. Main engine fuel flow is controlled by the DEC when operating in primary mode, and the MEC fuel flow control is in standby mode. Secondary mode is activated manually by placing the engine control switch in the secondary position, or if the DEC detects certain failures. In SEC, the MEC provides fuel flow scheduling, in addition to the functions it provides in primary operation. During SEC operation, the SEC caution light is illuminated, afterburner operation is inhibited, and the nozzle is closed, raising idle thrust. Bleed air is extracted from two separate stages in the compressor. Low pressure air from the fifth stage is used for turbine cooling and the engine anti-ice system. Low pressure air and high pressure air from the ninth stage is taken for airframe use. Low pressure bleed air is used for the environmental control system. If pressure is insufficient, high pressure bleed air is used. High pressure bleed air is used for the nacelle ejectors and to power the emergency power unit. On the ground, the ejector nozzles blow bleed air through the nacelle, reducing the risk of a nacelle fire. There is sufficient airflow in flight to ventilate the nacelle. To check the aircraft and FLCS batteries before engine start, set main power to battery. External power or main generator are not connected to the electrical system. Standby generator power is not available. One or more FLCC branches are not connected to the aircraft battery, or voltage is below 20 volts minimum. The caution light illuminates in conjunction with any of the above lights. The engine is operating in secondary operating mode, or main fuel pump pressure is low. To test FLCS, hold FLCS power test in the test position. The FLCS relays close but do not latch. The aircraft battery to FLCS light illuminates, the FLCS relay light goes off, and the FLCS power lights on the test switch panel illuminate, indicating correct FLCC power output. Return FLCS power test to the normal position. Set the uniform and Victor radios as desired. Rotate the COM1 and COM2 power knobs clockwise to increase uniform and Victor volumes respectively. The mode knobs have three positions: off, squelch, and ground. Squelch mode is used to reduce background noise. Guard mode tunes the main receiver and transmitter to the guard frequencies, which are Uniform 243.0 and Victor 121.5. To set Sidewinder acquisition sound level, rotate missile, and to set the volume of the threat warning system, rotate threat. To control headset volume, rotate intercom. When rotating ILS clockwise, power is applied and the volume of the localizer identification signal increases. This panel controls the backup uniform radio. There is no backup Victor radio. The backup radio is active when CNI is in the backup position. The function knob has four positions: off, main, both, and ADF. In the main position, and with COM1 power on, uniform operates on the selected frequency. In the both position, uniform also receives on the guard frequency. The ADF position is not operational. The mode knob has three positions: manual, preset, and guard. In the manual position, uniform frequency is selected with the 5 frequency knobs. In the preset position, frequency is selected with the channel knob. And in the guard position, the main receiver and transmitter are tuned to the guard frequency. To activate HMCS, rotate symbology clockwise and continue to turn it to increase intensity. Set stores config to Cat 1 or Cat 3 according to the aircraft loadout. The stores config caution panel light illuminates if the position is not set correctly. Set landing taxi lights to taxi. The landing gear handle is in the down position. Ground jettison enable is off. This switch is used to enable jettisoning of stores while on the ground. The emergency stores jettison cover is intact. When pressed for more than 1 second, all air-to-ground stores and external fuel tanks are jettisoned. Hook is in the up position. The 2-position toggle switch operates the emergency arrestment system. Roll is in the attitude hold position. When in the attitude hold position, the autopilot maintains current roll attitude by INS. In the steering select position, the autopilot directs the aircraft to the active steer point. Note that the roll switch is functional only when pitch is engaged in altitude hold or attitude hold. Pitch is in the autopilot off position. In the off position, autopilot is not active. In the altitude hold position, the autopilot will attempt to hold the current altitude, while in the attitude hold position, the autopilot will maintain current aircraft pitch. Master arm is in the off position. Laser arm is off. Radio frequency is in the normal position. RF controls electromagnetic emissions from the aircraft. In the normal position, the applicable aircraft systems operate normally, while in the quiet position the radar is put into standby mode to reduce emissions. In the silent position, all emissions from the radar, terrain following radar, radar altimeter, and electronic countermeasures are shut down. Voice message is in the voice message position. This switch controls the voice messaging system. In the inhibit position, Bitching Betty is muted. Set the HUD control panel. In the VV/VAH position, vertical velocity, altitude and heading are displayed on the HUD. Vertical velocity is displayed inboard of the altitude tape and is marked at 500 feet intervals with a caret, indicating the velocity vector. A roll indicator is displayed above the FPM. In the VAH position, the HUD displays velocity, altitude, and heading. In the ATT/FPM position, the pitch ladder and flight marker are displayed. In the FPM position, only the flight path marker is displayed. In the DED data position, the DED is displayed. In the PFL position, the pilot fault list is displayed. This is used for standby bombing mode. In the CAS position, calibrated airspeed is displayed. In the TAS position, true airspeed is displayed. TAS is calibrated airspeed, corrected for pressure altitude. In the ground speed position, the speed tape displays ground speed, which is true airspeed, wind corrected. In this mode, a caret is also displayed on the heading tape. The caret indicates that the system is now showing heading as wind corrected ground track rather than magnetic track. Note that whenever the landing gear is lowered, HUD airspeed uses calibrated airspeed regardless of switch position. In the alt radar position, radar altitude is indicated. In the baro position, barometric altitude is displayed. And in the automatic position, the altitude scale indicates barometric altitude over 1,500 feet and radar altitude below 1,500 feet. In the day position, brightness will be set to a range from no visual perception to full intensity. In the night position, brightness ranges from no visual perception to 1/20th of full intensity. In the automatic position, an ABC sensor is used to maintain a pilot-selected potentiometer setting. The ABC adjusts the brightness of the symbology depending on the ambient light intensity. The range of the automatic setting is 1/100th of full intensity to full intensity. If the ABC sensor fails and the brightness switch is set to automatic, brightness will default to the day setting. The test switch controls the display of 4 HUD test patterns. Set interior lighting as desired. Flood consoles controls the cockpit flood lights. Primary instrument panel controls instrument backlighting. And the data entry display knob controls DED brightness. Each knob has 3 positions: off, dim, and bright. Set air source to normal. In the normal position, the air conditioning system is in normal operation and provides automatic temperature and pressure regulation. In the off position, the engine bleed air valves are closed and air conditioning, cooling and pressurizing functions and fuel transfer from external tanks are not available. In the dump position, cabin pressurization ceases and the cockpit vents to external air pressure. Cockpit pressure will therefore increase above 8,000 feet MSL. The cabin pressure caution light illuminates if altitude exceeds 27,000 feet. Fuel tank pressurization and the other ECS functions are not affected. In the ram position, engine bleed valves are closed and the cockpit vents to external air pressure. Ram air valves are opened and ventilate the cockpit and avionics. External fuel tank pressurization, cooling, and the other ECS functions are disabled. Set main power. The generator is now armed. Close the canopy with the canopy handle. Wheel chocks are in place, a fire guard has been posted, and intake and other danger areas are clear of ground crew. The JFS is an independent gas turbine, started by 2 JFS/brake accumulators and charged automatically by hydraulic system B. To vent one or both of the brake/JFS accumulators to the hydraulic start motor, place the JFS switch in the start 1 or start 2 position. The JFS spools up and the engine turbine shaft is driven to 20 to 25% RPM. The JFS run light illuminates. At approximately 20% RPM, the SEC caution light extinguishes and the throttle can be advanced from the idle position. RPM now continues to rise. The FLCS PMG light extinguishes at around 40 to 45% RPM. At 50% RPM, the JFS switch returns to the off position. The engine can now spool up alone, and the JFS is shut down, the main generator comes online, and the battery is taken off the bus. The standby generator light is off. The main generator light will extinguish around 10 seconds later. At 60% RPM, the engine and standby generator caution lights extinguish. The hydraulic and oil pressure caution lights extinguish between 15 and 70% RPM. With throttle in the idle position, fuel flow is between 700 and 1700. Oil pressure is minimum 15 psi. RPM is between 65 and 77%. Fan turbine inlet temperature is 650 C maximum. Nozzle position is greater than 94%. In primary mode with the landing gear handle down, the nozzle is greater than 80% open at idle and closes as throttle is advanced. The nozzle controls engine thrust for optimum performance through the flight envelope and maintains fan stall margin by varying the nozzle area. The exhaust nozzle consists of two sections. The divergent nozzle floats freely and moves in conjunction with the convergent nozzle. The convergent nozzle is controlled by the convergent exhaust nozzle control, which is actuated by a high-pressure bleed air motor. Hydraulic pressure is supplied by two 3000 psi hydraulic systems. The systems operate simultaneously and supply hydraulic power for the primary flight controls and leading edge flaps. System A also supplies power to the fuel flow proportioner and speed brakes. The fuel flow proportioner depletes fuel at equal rates from the forward and aft tanks, maintaining the centre of gravity of the aircraft. The remaining utility functions, gun and gun purge door, air refueling system, landing gear, brakes, and nose wheel steering are supplied by System B, which also charges the brake/JFS accumulators if the engine is rotating at a minimum of 12% RPM. Recharging takes 40 to 60 seconds depending on the conditions. The systems are powered by two independent engine-driven pumps located on the accessory drive gearbox. Each system stores hydraulic fluid in its own reservoir and FLCS accumulator. The reservoirs are pressurized by their respective hydraulic system, ensuring positive pressure at the pump. If demand exceeds pump maximum flow rate during rapid control surface movement, the FLCS accumulators provide additional hydraulic pressure. If one hydraulic system fails, the remaining system provides sufficient hydraulic pressure. If both systems fail, a hydraulic pump located on the EPU provides hydraulic pressure to System A, and the FLCS accumulators provide adequate hydraulic pressure to the flight controls while the EPU comes up to speed. The hydraulic system is a dual redundant system. A and B serve critical systems which fail only if both A and B lose pressure. Hydraulic pressure A and B are between 2,850 and 3,250 psi. The main generator is now online. All systems are receiving power, systems previously set should come online, and we can now continue to power systems. Feel free to like, comment and subscribe.